Hi, I'm Daniel Black. I'm the Chief Innovation Officer at MariaDB Foundation. I'm presenting to you from Canberra, Australia. It's spring here, and like spring, a fertile, mature code base with a vibrant ecosystem and a foundation keen on nurturing your ideas will help, and its own, will help deliver MariaDB server innovation to you. But who are you? Who are the people to which MariaDB matters? And we start by answering this question by looking at the download statistics off our downloads page, on our new downloads page, and we see that most packages are actually Windows that downloads. And while it's certainly acknowledged as a big proportion, we know it's more than just that. So if we take a look at the source code where it starts and look at how it's distributed out, we know that a limited number of people actually use the source code directly. So how is it distributed and consumed? So the MariaDB Corporation and the MariaDB Foundation together produce a number of Linux and Windows distributions. The Linux distributions include CentOS, Fedora, Debian, Mint, which is basically Ubuntu, OpenSUSE, RHEL, SLES, and Ubuntu. And we've given instructions for some other distros as well. So on non-Linux distros, there's AIX actually produce MariaDB via Bull Freeware and AIX Toolkit. Homebrew produce packages for MariaDB for Mac OS, which also work on Linux, apparently. I haven't tested. There's FreeBSD, and there's Open Indiana as an Open Solaris-based distribution, which are all maintained with many thanks to the distribution maintainers there and looking after their community. Linux distros, in addition, produce their own packages, and Windows is listed here because it's got a subsystem based on Ubuntu, and all the distro maintainers there do an excellent job sort of packaging it up as well. The Ubuntu packages produced by MariaDB are distributed further and packaged up into the Docker library containers of MariaDB. Based on the 2004 packages, and these are pushed to Docker Hub and as a container images for all the architectures that we actually distribute MariaDB for. If we look at how the Docker library image is consumed, it's pretty much any time you use MariaDB in a Docker compose file, that will be using the Docker library file, most likely, without any setting changes. However, there's other uses such as MailCow of Liston and Ibis as projects that just use the container directly in their projects, and you might be using it the same in yours. The Docker library can also be used on Travis CI to test a number of open source and proprietary projects against the Docker container of MariaDB, packaged up by the Docker library. The Docker library package of MariaDB is also consumed by OpenStack in their Trove product, which is their database as a service, which, along with 11 other databases, provides an integrated part of the OpenStack infrastructure as a service platform. MariaDB is also used within other projects in OpenStack, like Keystone, their identity service. If we look back at the Windows packaging, it gets packaged up by Apache Friends to XAMPP, which is a bundling of Apache, MariaDB, PHP, and Perl. And this is available for Windows, but also OS X and Linux. So XAMPP is currently maintained by Bitnami employees as a community contribution. However, Bitnami actually, as a VMware company, have a main product against MariaDB containers, and they produce a Debian rootless form of a container, which provides added security in the way it's packaged up. Bitnami also produce a virtual machine for download, and obviously that runs on VMware, but it's also available VirtualBox as well. Bitnami also provides some Helm charts for Kubernetes deployment of MariaDB, and that's used in a number of situations, namely Nextcloud, which runs their own Office environment, and this is one of the uses of the Helm charts. OwnCloud sort of forked off Nextcloud considerable number of years ago, and they actually use a MariaDB image based on Alpine, and they use that as a common storage platform for all their backend services. So Bitnami and Docker Library aren't the only ones actually producing container libraries. Red Hat have got like their own container platform, which is freely available as well. Bitnami, through the cloud marketplaces, allow you to deploy MariaDB directly onto Google Cloud Platform, AWS on Amazon, and Azure. But you know, these aren't the only providers. There are a significant number of other providers that provide deployment to any of the hyperscale data centers of Google Cloud, Azure, Amazon, Alibaba Cloud, Tencent Cloud, IBM Cloud, or into service provider like ServiceNow. Bitnami's, I forgot to mention, was also produce either a single instance service, or you can deploy a multi-instance replication topology with minimal effort. And so this shows, you know, that even down these stacks, they're adding value and making it easier for users. There are a number of database as a service platforms that strongly integrate the infrastructure tooling into a really self-contained product, and these include like SkySQL, which is a MariaDB Corporation product, Amazon RDS, MariaDB relational database service for MariaDB TX, and that's from Alibaba Cloud. And these are just some of the beginnings of a large competitive market producing MariaDB as a service offering. So as we sort of zoom out and we look from like the beginning of the source to the packaging, to the repackaging, up to the hyperscale data centers, we see the vibrancy of the ecosystem, MariaDB source code, to drive so much diversity in the ecosystem. This certainly isn't a complete picture. Even just scratching this itch on, you know, the finding the source to large scale instances doesn't explore all the paths, and there's certainly a number of significant paths that most developers, users, and me don't even know about. But this is actually more than just a distribution chain. What it shows here is the degree of innovation already in the ecosystem. Each of these elements has taken MariaDB of a form, added value to it, and allowed you as a user to consume it at free or minimal cost. But what we see in the consumption of MariaDB is beyond just what it got delivered to you, it's how you use it. And we can start by saying that SQL is not like the terminal interface where you manually type SQL like Raymond Boyce and Donald Chayman and kind of envisaged 50 years ago. The SQL terminal approach contributed to the large portability of the language and its growth in adoption, and it still serves a purpose in like testing queries and scientific learning and one-off business analytics. Robert's kernel Juniper kernel talk later talks about this interface and how it's been kind of reinvented as a Juniper notebook. However, for the most part, your applications actually consume MariaDB via connectors. These are language-specific constructs like connector C, connector J, Node.js, PyMySQL, ODBC, JDBC, PHP in a number of forms from MySQL to PDO, transform how a database is consumed by an application. And these provide a network layer and the marshalling required to talk to the database. And as an application interface, it's pretty much largely SQL at this layer. That may not be enough for you. There's other frameworks like Doctrine, Django, Drupal, Type ORM, Laravel, SQL Alchemy, but the list has really got too large, and these provide a number of ways to make SQL look more like code or objects, as the case may be, or just as a database abstraction layer if you're targeting more than databases. And this layering sort of builds on the connectors underneath and provides an added value into the way you write your code. At the end of the day, some of you may be even using a higher level framework than that. Things like WordPress, Wikimedia, Joomla, OpenCart, or hundreds of other applications provide an extensible framework to their domain, such that you can extend this and write your own application, even if it's largely a set of configurations of plugins and extensions. And these will just use MariaDB at the back end, but abstracted away. In addition to the application stack, there's a bit of infrastructure that's also needed around MariaDB. And the first set of this is around orchestration. In a sense, the distribution of packages is a kind of orchestration that allow you to reproducibly install the same product, but it also extends more to things like Puppet and Chef, more recently Ansible, Docker Swarm, OpenStack and Kubernetes, to name a few that provide a reliable, repeatable way of delivering actually the same MariaDB service into production. On the infrastructure side, to monitor databases, you need different tools like Prometheus, like Percona management and monitoring, PMM, like cluster control, like Monuing, to name a few that integrate with the server and provide meaningful statistics on what it's actually doing. To have high availability and horizontal scaling, there's additional products like MaxScale, HA Proxy, Orchestra, and Galera, to name a few that enhance the ability to move across multiple environments, be redundant against failure, and just to deliver more throughput for the same server. Backup tools from like MyDumper to MariaDB Backup are part of the infrastructure, and their compatibility needs to occur. In the tooling realm, there's GUIs like PHPMyAdmin, query analyzers, Juniper notebooks to MyCLI, MySQL Tuner, and all these provide advantages to make the most out of MariaDB and make it easy. And lastly, I want to actually cover like multi-user services. So things like Plesk and WebMin and VirtualMin provide like a management interface to MariaDB used by service providers that give multiple users a specific view of the database. Things like OpenStack and Kubernetes and OpenShift also actually provide a similar kind of granularity in giving users a large control of the infrastructure, and in theory in a way that sort of can limit the impacts on everyone else. And so by looking at like the distribution ecosystem, the application layers, and the infrastructure tools, each of these independent providers actually work hard to deliver added value to you that you can deliver on to someone else, i.e. your customers and users, who at the end of the day should be oblivious to the fact that they've got a transparently infrastructure stack that's powered by MariaDB underneath. Okay, so now that we've sort of covered, how it kind of expands as far as distribution and use, I want to actually take a little bit of time to focus on how does it start? So the server development of MariaDB occurs in development and test iterations, and every now and then out of these pops a release. And the process repeats. So for connectors that aren't strongly tied to the development of server, at some point in time after the release of the server, those connectors actually pick up new features of the server, integrate them into their connectors, and they push out a release sometime later. If we continue further down the application stack, we see that frameworks, in a similar way to connectors, will wait on a release of a connector, see what features it exposes, and then try to actually incorporate that into their product. And as we can see, even though that this is really transparent, it happens all the time. The API is a backwards compatibility. So the development of the framework and the connector layers largely occurs asynchronously. How if we look at, new features, it takes some time to actually propagate through the development communities to get to you. And so what I'd like to, every now and then, bugs happen and they need to go back to the layer that introduced the bugs. And, it's software, it's not infallible. Bugs will get fixed, and that delays the delivery of new features down to you. What I'd like you to imagine for a moment is if the development process looked like this, that the server development occurs at the same time as the connectors development, occurs at the same time as the framework development. However, because a lot of the connectors and the frameworks are open source, they've got a rather minimal environment to get them going, and they've got their own test suite. So why not bring those aspects of the test suite, clone them down in a continuous integration and testing, so that the development of new features can start to be tested against the framework at the same time as the connectors are being developed and the server is being developed. And that way, when bugs are actually found, they're actually found before the release. And yeah, this is what I imagine it would look like. This is all really very new as far as a concept. Would have liked to actually show you more, but for instance, here's what we've got as a PHP build environment. It's not too hard, it's not too complicated. There's a few dependencies. A Docker file definition is all it takes to define what's needed to build, and along with some volumes and an entry point that starts the build process. Now, on that entry point, it's a combined build / test script. Don't worry about looking at this too closely, but this shows us cloning down a source code into repositories, doing a bit of caching to make sure we're not doing it every time, checking out the stable and development versions of PHP. And if we look at how PHP actually interacts with MariaDB. There's two main interfaces, the MySQL ND and there's the connector C interface. And so both of these have to be sort of compiled and tested separately. And on top of these two mechanisms, there's a bunch of PDO connectors that are presented in a different way, so we test those too. And this is the beginning. We've started to plan out on how to use this for other things and how to actually write a full stack of integration and testing. And we're not writing the test suites ourselves or the test cases, but we'll use what test suites are out and include those as part of our development process. This doesn't actually apply to the application stack. It can equally apply to the distribution stack, and examples such as DB deployer and Docker library are things that quickly sort of package up and use MariaDB as a package and also have their own test suites. So those are actually perfect to integrate in the same way. We're not going to achieve 100% coverage of these. However, with a careful selection of the communities that we want to test, we can pretty sure we've covered a significant portion of the server and of all the connectors in between. So it's likely that even though we're not covering 100%, that the things out there are using the same interfaces, so they're going to be bug-free by the time it's released. Well, that's the plan anyway. So all this building and testing infrastructure is off BuildBot. MariaDB Foundation has its own BuildBot, which has been running a significant number of architectures and compilers for quite a while, and operating systems to ensure that MariaDB Server is well tested when it gets to you. So we plan to continuously expand the range of testings to cover a sampling of the ecosystem of the application stack, of the infrastructure stack, and of the deployment stack. However, there's another direction I haven't actually mentioned. MariaDB depends on compilers and libraries to build itself, and these continue to evolve in ways that, compilers that change the way they transfer source code to object code. Libraries continue to add new interfaces and obsolete old interfaces. And without CI on these, it's hard to keep track of. We certainly don't want the case where a new compiler generates the wrong code and a user's stuck with a database corruption. So, let's try to find these faults early. Kernels from the Linux kernel, the Windows, BSD kernels to Illumos Open Solaris kernels provide new implementations and the compatibility needs to be tested. Multiple file systems are provided by Linux, and as database performance is heavily dependent on an efficient file system, this should be something we're actually testing frequently to ensure that the performance of MariaDB isn't getting degraded or regressed, potentially through code that isn't our own, i.e. kernel code. Also, kernels provide newer features like libio uring that provide ways of doing I/O better than what was previously provided. And we should have a testing ground for those and making sure that they've got a path into MariaDB codebase, and that we're actually sort of testing those not only from a functional perspective, but also from a design perspective. Are they actually going to be doing something that is useful for us, and perhaps offer suggestions on how to do things better? So how else is MariaDB Foundation serving you? I initially mentioned at the start that we've created a new downloads page. We've done this by cleaning up a lot of the user interfaces on these, auto-detecting the operating system and architecture that you're running on. And so what this will give you is actually a server product with less clicks and less confusion. We've also expanded the use of mirrors, particularly on the RPM-based distributions, so you should be able to get a faster download. Because we kind of acknowledge and see that the distribution stack is really extensive, innovation that was provided here was an API of versions and URLs and checksums on how to get at least like the first layers of distribution out. And so these can be used further down the track and to trigger the distribution in a more automated way. MariaDB also works on assisting contributors, whether it be a minor fix to get OpenBSD fully working on MariaDB, or whether it's helping some contributors actually provide like an alternate existing way of achieving their goals that they didn't realize was there. And sometimes we help contributors get past the trickier parts of serverless implementation, like this Unix time zone implementation. So gave them tools to get past the task and allowed them to continue development and writing the tests because, hey, everyone likes finishing a project they started with, but not getting stuck down on the hard bits. MariaDB works by connecting communities when we kind of notice a bug report, well, something that looks like a bug in one forum that isn't reported into the bug tracking of the server. So in these cases, we noticed something was wrong. We alerted the people that had the knowledge and the skills to fix it, and they got fixed really quickly. However, breakdowns can actually happen. In this case, the Docker library, what happened was MariaDB fixed a time zone initialization for Galera, which really hurt other users on slow storage hardware that were using the Docker library. I guess developers actually test and run on fast hardware, so sometimes they actually don't notice these kind of effects. This fix for Galera was only meant to be for Galera, but due to its bug, it wasn't. So this was corrected in the next release. And it, from a MariaDB perspective, was like, okay, that's all fixed. Let's solve all the problems. However, some of the people in the Docker library land knew it wasn't totally fixed, and they lacked a really clear communication to say what it wasn't fixed. There was communication in circles about which versions were fixed and which versions weren't. And so what we needed to do was, pick it up at a bug and do some more investigation. After spending a bit of time, we isolated the problem that there was a second transparent, well, non-obvious cause of like the same bug, which was in 10.3. The crash-safe ARIA engine started to become the default of the system tables, including those that store time zones. And it doesn't actually work so well on slow storage, especially with like 7,000 inserts of time zone transition, and each of these occur with an F-sync between them. And so what we saw is, yeah, large degraded performance on these. We were unable to get a fix or really write a fix for the next MariaDB release. So we pushed a workaround to the Docker library. And so before they pushed out their next MariaDB version release, they had a workaround to work with. In the process of actually looking through these bugs, we also improved the Galera InnoDB-based time initialization, and just looking at how Docker library uses MySQL InstallDB, we realized that it's a little bit dated and probably hasn't significantly changed since early MySQL 5.6 or 5.7. So it's in time for a revitalization. So were the Docker people, library people, happy with this? Their comment on the report that says 3 minutes down to 7 seconds was, pretty compelling. And so that was just a workaround, and work continues to improve this. And hopefully with the CI, we'll catch this sort of problem ahead of time. As I mentioned with MySQL InstallDB, it's used by a number of different communities, so I felt it was important to engage and write them up with a prototype and say, okay, this is how we're proposing to improve it. Does it cover all your use cases? And we've tried to actually make it fairly generic here, taking an extra file descriptor here so you can inject SQL into the bootstrap process, which is used certainly a lot with container-based instances, and certainly not the server installs where it was designed for. MariaDB helps out by helping users, whether that be on the MariaDB Knowledgebased, on Stack Overflow, on DBA Stack Exchange, on Reddit. Users come into problems, and yeah, they sort of need a bit of help and direction getting over things. So the MariaDB Foundation, it's people are looking at those forums to look for those kind of things. And occasionally on those things you'll see, bug reports and things that need to be fixed, or just ideas that need to be improved on the server to make it a better usable product. MariaDB also has its staff doing its own self-directed innovation, and Robert's Juniper notebooks, I mentioned a couple of times, is a great example of this, and I strongly recommend you watch his talk. Another feature request I wrote, or feature improvement I wrote, was improving MySQL dump. So instead of dumping out system tables, there's in a bunch of create MySQL.user, insert into MySQL user. We now put it as like portable SQL, like create user. And this applies to other things like roles on servers and a number of aspects that we see throughout the MySQL system tables, such that they can be imported in and a lot more portable between the versions. And so I plan on getting this into the next release. So the MariaDB Foundation also significantly works on the knowledge-based documentation. As you can see, it's pretty much all done by Ian. So thank you, Ian. You're doing a great job in making sure all the MariaDB features are explained in a way that's actually usable. The MariaDB Foundation also creates podcasts on various topics to make it easier for the users. And sometimes we're just running or presenting at a MariaDB Server Fest. So another idea I've had on the back burner for a while, but I haven't had a chance to implement, but I thought I'd just share it with you as an idea. Load data actually works really great until there are errors, at which time the user is stuck and needs to resort to either splitting large text files or a complicated set of sed commands to clean up the data as it goes in, or write a looser table structure so it actually accepts the data, or writing your own import array. And all of these are really, really painful alternatives for what's something that's meant to be quick and fast and automated. So Oracle's database has an SQL loader that has a bad kind of data file where errors in the loader are actually pushed out to this file. But I think we can do better than that. So in this example, I've got a database of my pets, their year of birth and their weight. Nice simple table with a little bit of data on my dog. Sorry, a little bit of inconsistent formats on my dog's Jovi's weight, which is 30 kilos. So what we do is like the sequence storage engine, not to be confused with the sequences in general. The sequence storage engine uses the name of the sequence with an automated header, i.e. seq, to define the structure and the row elements in the sequence. So this was called like table discovery, and it was a large bit of innovation that was written by Sergey Golubchik in 2013, and it allows us to do a similar thing based on the name. So a structure that I'd like to see is, say, a load data errors table that is auto-created, and what this has is things like line numbers of the source code, of the data file that is read in, the full line of like that was read in that contained the errors, just in case you've got a delimiter error. It's got a enum that describes which column had the error, and we've got like error codes and error text to make it all readable. And then what we do is we include each of the rows that were, each of the columns that were in the original table, and we make them nullable just in case it couldn't parse them. But beside those, we put out the parsed broken up text that was part of the original CSV file. So for my pet database that loaded, if we extend the load data syntax to refer to this load data errors table, what we get is a table here that has like one entry that contains that line number 2 has an error for in the weight column for Jovi. It couldn't really parse the weight, but it had its original text form as 30 kg. And so what this will make it useful for is with really large data imports or scripted imports, that you'll get tables with something you can actually do something with. And you can do something with it in SQL rather than writing a scripting or a language around importing CSV files. Because, hey, you used load data because you didn't want to do that. If you've got any further ideas on enhancement to this, please make a comment on Mdev 13046. And yeah, I mean, there's a number of concepts that haven't been explored. For example, if do you want more than one error table per for target table? Do you want like the file name introduced as one of the columns and make that a joint primary key? It's all possible, but yeah, tell us your ideas. Load data isn't the only thing that can actually generate a bunch of errors. Things like alter table can lead to lossing conversions, and maybe it's worthwhile to actually have some of those losses like captured, rather than, you know, them A, being either silently ignored, or B, you know, your alter table failing halfway through and needing to roll back on that. Another case is where the feature of SQL's strictness can come a little undone is, say, in replication. That data pushed through from the master side to the replica side isn't always the same, or has the same effect. Table structures can be different, so maybe we want to capture those kind of errors in the same way. We also at MariaDB Foundation acknowledge there's a backlog of feature requests, and these we need to actually get through and deliver on the things that actually matter to you. We know by looking at the code base, there's other, you know, fertile grounds for further development of the MariaDB server. The engine-independent table statistics was written in version 10.0.1, and it provides the framework for choosing better optimal query plans on running servers, on running queries. The table discovery, like I mentioned with loaded data, has a number of different applications, and yeah, it's ready to use. Functions, as of, I forget which version, there's actually an aggregate features that is available. Additional authentication mechanisms are possible, especially since like 10.4 actually has the ability to do multiple authentication mechanisms that are actually possible for a single user. So there might be opportunities for enhancement or integration into other products and systems for that. Encryption plugins, which were written either 10.0 or 10.1, also are a rich avenue for providing ways to encrypt the storage of data. And there's standards like KMIP that might be something that's portable and ready to use in that respect. And these are just some of the ways that MariaDB delivers a better server for you. We want to ensure the ecosystem is compatible. We'd love to hear about your feature requests and bug fixes that you want fixed, so please vote on these. Please write up your ideas for new feature requests, or just talk to us about problems that you have with working with MariaDB and SQL in general. And, you know, we'll see, you know, what can be done to improve those. We're happy to help you develop your own features, particularly if you want to actually make them available for everyone else in the server code base. And we'll use our collective knowledge to continue to make MariaDB better, because it's all about you. Thank you, everybody. Bye. Any questions?